Hey everyone, this last video for section 2.1 is just going to be chock full of examples for solving linear equations. And I am including examples that have fractions and decimals because they're a little bit trickier. So we're going to look at a strategy for dealing with decimals and fractions. Right here we have 1/4 x minus 1/2 equals -3/4. And I could do this the normal way by adding 1/2 to both sides and then dividing, but we still have fractions throughout. And we want to work smarter, not harder, right? So what we can do is clear the fractions from the equation. And we can do that by multiplying by a common denominator. If we look at the denominators we do have, we can choose 4 as a common denominator. And of course, we have to distribute. But the idea is this. We end up with 4/4x minus 4/2 equals -12/4. And once we simplify that, we see that we have x minus 2 equals 3. By multiplying both sides of the equation by a denominator that is common to all of the others, we can effectively get rid of all of the fractions. So here all we have to do is add 2 to both sides, and we end up with x equals 5. Moving on, we have this guy here. Again, I want to multiply by a common denominator to clear the fractions from my equation. So looking at my denominators, 2, 4, 6, and 12, it looks like I can choose 12 as a common denominator. Again, we gotta distribute. So we have 12/2a minus 12/4 equals 12/6a plus 12/12, which reduces to 6a minus 3 equals 2a plus 1. And now we can collect variables on one side. So I'm going to subtract 2a from both sides. So leaves me with 4a minus 3 equals 1. And then collect the constants on the other side. Do that by adding 3 to both sides. So we have 4a equals 4. And upon dividing both sides by 4, we end up with a equals 1. Not too bad. All right, so here's another example of fractions. We could start this off by trying to clear the fractions from both sides. But let's maybe take a step back and look at what we have here. So we have 4n plus 8 all divided by 4, and that is equal to n/3. So on the left-hand side, notice that 4 is a factor both of the coefficient of n and this 8 here. So I could use the distributive property in reverse. In other words, I'd be factoring. And hey, now this fraction reduces. So I have n plus 2 equals n/3. And I can clear a fraction by multiplying both sides by 3. Of course, I have to distribute. So I have 3n plus 6 equals 3n/3. And I want to collect the variables on one side. So I'll have 6 equals negative 2n. Now I want to divide by negative 2. So I'm left with negative 3 is equal to 10. So let's take a little bit of a closer look at this step here, which is perhaps mysterious, but 4 times n plus 2, you can check distributes as 4n plus 8. So they really are the same thing. And being able to go in this direction is also going to be useful for us. So it's something to keep in mind for the future. We'll have more practice with it later on. Next up is an example with decimals. And we're going to approach equations with decimals similarly to with fractions. We want to clear them to make whole numbers and make our lives a little bit easier. And to clear decimals, all we have to do is multiply by the right power of 10. So you see here that the only decimals in this equation have 1 decimal place. So if I were to multiply both sides of this equation by 10, all the while remembering to distribute, and then I would end up with 4x plus 6 equals 5x minus 12. Want to collect variables on both sides. So I'm going to subtract 4x from both sides. I'll end up with 6 equals x minus 12. And then I'm going to add 12 to both sides. And so I have that 18 equals x is my final answer. All right, last example. Same deal as the previous one. We want to clear the decimals, but we need to choose a power of 10 that is big enough to make sure we get rid of all of the decimal places. So 10 is not going to work because if we multiply 0.25 by 10, then we're going to get 2.5. So I have to multiply by 100. Now here's something that can trip you up. Terms are separated by addition. So inside this pair of parentheses, I have 2 terms, this 0.1 times d and this 0.25 times d plus 7. So even though there's a plus sign here, it's being multiplied by 0.25. So since these guys are smushed together with multiplication, it's really just counting as one term. So when I distribute, it's only going to those 2 terms. So 100 times 0.1d gives me 10d. And then 100 times 0.25 times d plus 7 is giving me 25 times d plus 7. You're not multiplying the 100 with both the 0.25 and the d plus 7. You're only multiplying it with one of them because they're one term. All right, gotta distribute again, which we're getting pretty good at. So we have 10d plus 25d plus 175 equals 525. Collecting like terms gives us 35d plus 175 equals 525. All the variables are on one side, so we got to move this 175 out the way. So we have 35d equals 350. we get t is equal to 10. And I think that's probably good on examples for the time being. So that about wraps it up for section 2.1.